second. There it is. So I am glad that you guys came. And any questions you may be having just to start? Okay, so let me see if I can do everything I'm going to do today. I'm going to share, hopefully I can share my screen. Okay, I hope you guys can see. All right, can you see my announcements, week 4 announcements?
Yes.
Awesome, thank you. Okay, so we start a new unit this week. We're going to start with proofs, and that's why. So right now I'm in a conference, and I am what's the word I'm looking for? I'm skipping some of my conference things that I should be going to because this is really important. I cannot just like every minute that we spend together is important because I'm giving you information that you need to do well in the class. So we will begin with proofs on propositional, also known as sentential logic. And today we're going to cover the implication rules, which are modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, simplification, conjunction, addition, and constructed dilemma. It's a lot to cover in an hour and 20 minutes. And I would like to do some truth tables too. So there's that. This is what we're doing. Also remember that their quizzes for the truth tables are due this Wednesday. And what else is happening? Wednesday I'll be in class in person. And then let me see. So remember, I got everybody signed up. So you'll click on the second link on Thursday at the time that we agreed for me to, one-on-one meet with each one of you. And we can go over how you're doing in the class. I also, if you did the journal assignment, I wrote in there how you're doing in the class. I would like to ask everybody to consider, I would highly encourage you to work on the extra credit assignments because that's, well, it's going to give you extra credit for one, but it gives you the opportunity to practice. And through the practice, you will see where you're getting snagged, what is not clear. So then when we meet in person for class and I ask if you all have questions, you can raise your hand and say, can we go over this? And then that way we can address your questions, right? So that's that. Any questions you may be having at the moment? Okay, so let me go just briefly do a couple of problems. Remember, an argument is a set of sentences called premises, right? That support the conclusion. So the argument is made up of statements. And those statements can be either statements themselves, right? Can be either true or false. The statements can be negations, conjunctions, disjunctions, conditionals, and biconditionals. So if you remember, statements can be true or false. Statements themselves cannot be valid or invalid. We've been going over that, right, for a couple of weeks now. This is our 4th week, so actually we've been going over it for now 4 weeks. In order for you to be successful at doing the truth tables, you must memorize these, the way that negations work, right? They just basically, you change the value of whatever you stick the tilde next to. Then conjunctions, you must memorize that conjunctions are only true if both conjuncts are true. And I recommend that you start using flashcards. So on one side of the flashcard, you can write, a dot for conjunction. And then on the other side, write the truth table for a conjunction. And so then quiz yourself, right? There's an element of memorization and logic. So you take your flashcard, and if you see the dot, have a blank sheet of paper next to you, and then just write out the truth table for a conjunction. And same thing for the other ones. And if you scramble up your flashcards and you end up looking at the truth table for a conjunction, then in your scratch sheet of paper, write, conjunction. So then this way you quiz yourself until you learn that conjunctions are only true when both conjuncts are true, that disjunctions are only false if both disjuncts are false, conditionals are only false when the antecedent is true and the consequent is false, and biconditionals are true when the value of both sides of the biconditional is the same. Any questions you may be having right now so far? About the value for statements. I'm going to get up and I'm going to go get a cough drop real quick. Okay, so let me go check to see if you guys have any questions. I don't see any questions. Oh my goodness. I'm glad I looked. All right, well, I'm glad everybody's here, almost everybody. And I was telling everybody that I am recording this. So I will give you the link afterwards so that you have it available to you. I just went over two tables for statements. Okay. And so statements are different than arguments, right? Arguments are made up of statements. And we did several. And remember, if there is an instance where the premises are true and the conclusion is false, then that argument is going to be invalid. Like this one right here. Because that's impossible, right? The definition of a valid argument is if the premises are true, the conclusion must be true. So if you run the truth table by an argument and you see that the premises are true and the conclusion is false, that tells you it's invalid. And everything hinges, you guys, on you being able to identify which one is, what type of statement it is, right? So the first premise there, it's a conditional. So then you need to know when our conditional is true and when our conditional is false, right? And then the negations. So that's that. I believe we did this one in class. That one was the last one that we did. And the thing with the long truth tables is that it requires quite a bit of focus on your part. So it requires you knowing the truth tables for the sentences, so you can tell, like you need to know when this, you need to identify the main connective of each statement. So the first premise is what kind of statement? Who can tell me? Just unmute yourself and speak up. No, it would help if I showed it to you. Yeah, so the first premise is what kind of statement? What's the main connector?
Biconditional.
Thank you. And so then when are biconditionals true?
When both have the same value.
Thank you so much. Yes, and so then, so we need to learn the truth tables for the statements. We need to know which one is the main connective, because there's a ton in there, right? So the first premise is a biconditional, so then we need to the left side of the biconditional is a conjunction. So we need to figure out when is that conjunction true, and the left side of the biconditional is a conditional. And so when is that conditional true, right? So then you have both of those on the sides, and that's how you determine the biconditional. And the same thing with that disjunction. So it requires us to identify the main connective, know the truth tables for sentences, and then it requires quite a bit of focused attention to make sure that you get everything exactly right, because if by accident you look at the wrong place and you write the wrong value, it throws everything off. And so I highly recommend in the quiz, I give 60 minutes, but I say, just take your time with it. There's no rush. I'd rather you do it and then go back and recheck your work. Obviously, this one is going to be 8 rows, so we're going to be there for a long time, right? It's 2 to the end. 2 because we have true false, so 2 is bivalent, 2 values, and 3 stands for the number of letters in our argument. So we have P, M, and T. So we got 3 letters, so 2 times 2 is 4 times 2 is 8. And the more rows we have, the more likelihood it is that we're going to make a silly mistake and get the whole thing wrong. And that's why, let me go to the next, and that's why we came up with the abbreviated or the short truth table method. And I would like to do a couple of them with you before we begin with proofs. Okay, so long truth tables with more than 3 statement letters can be impractical to construct. Abbreviated truth tables provide a much more efficient method for determining validity. And the way that it goes is, if you can construct one row of a truth table for an argument that makes the premises true and the conclusion false, then you have shown that the argument is invalid, because it's possible to have all true premises and a false conclusion. And if you fail at that attempt, so if you cannot, you try but you cannot, then you know that the argument is valid, rather. Okay, and we try this one. So let me write it down. We'll do it again. Let me see. I believe I have a whiteboard here. Can you see my screen, my whiteboard?
Yes.
Okay, so the argument says A or B. That's premise number one. Not A, therefore B. Okay, so I'm going to cut to the chase. I have two letters. But what I'm going to do is I'm going to make the premises true and the conclusion false. So then I go back and I plot what I wrote. B is supposed to be false. If not A is true, that means that A is what? Right? So then, is this possible right here? Is it possible for me to have two false disjuncts and a true disjunction? And the answer is no, right? If you remember. If you remember, the only time that a disjunction is false is when both are false. So I tried to invalidate it, and this is not possible. It's not possible for me to have two false disjuncts and a true disjunction. So the argument is what, you guys?
Invalid.
This argument is valid because this is not possible right here. I tried to make the premises true and the conclusion false. In order for me to have all true premises and a false conclusion, B has to be false, right? Right there. And if this premise right here, if this is true, then A is false. Okay? But then when I come in here, if I have two false disjuncts, this would be false. But I can't, in other words, I cannot have all true premises and a false conclusion. And so since I cannot have all true premises and a false conclusion, that means the argument is valid. Let's do more because that's how that's like, practice is how we do things. So this comes from my notes. And another thing that I wanted to, it's called, the seminar where I'm at right now is called Southwest Seminar for Great Teaching. So I'm learning how to be a better teacher. And one of the things that I learned that I am going to ask you is to watch my videos before you come to class. So then that way you come to class with questions. Either E or S. If E, then B and U, not S or not S or not U. So therefore B. Okay, let's come back. Now we're going to do another one. Any questions on this? I think I can do another one right here. Okay, so this is my next argument. It's E or S. If E, then B and U. Oh, this one's really big. It's a big, this is an eraser. So I cannot make it so big. Okay, so the letters I have are E, S, B, U. E, S, B, U. And the argument, either E or S. If E, then B and U, not S or not U, therefore B. Let me make this a little bigger. And I go back and recheck to make sure I wrote everything down. E or S, if E, then B and U, not S or not U, so B. So first thing I need to do is obviously write down my argument, right? The letters on the left and the argument on the right. If this was a long truth table, how many rows would I be having? 2 times 2 times 2 times 2, right? I would be in there forever. So it's much nicer to just abbreviate it. And in order to abbreviate it, I'm going to look for the main connective of each statement. I have 3 statements, 3 premises. I'm going to make the premises true and the conclusion false. Okay, so then I go back. B, so I'm going to attempt to invalidate this argument, right? So B is false, and I go in there and I write in there. Okay, let me see here. And I work backwards. So if B is false, I just have to work backwards. Let's just start with the first premise. A disjunction can be true how many times? Do you remember? 3 different times, right? So since it's true, it could be this one. So let me try that one. I'm going to make both disjuncts true. And we'll see what happens. So if I make E true, wait a minute, that's not going to work, right? Because in order for a conjunction to be true, both conjuncts have to be true. And if F has to be false, yeah, because I need to have a false conclusion, right? I need to have all true premises and a false conclusion in order for me to invalidate it. So B has to be false. So you know this conjunction is going to be false, right? So E cannot be true. I'm trying to invalidate it. E cannot be true because if this is true and I have a false, if this is true and true antecedent false conclusion, that would be false, right? So that's okay. This one, I can't invalidate it. It won't work. Okay, so B has to be false. How about if this is if the conditional statement has to be true? Do you remember that one, you guys? Let's do it like this. I'll put it in here. This is what you have to memorize, okay? I'm doing it for you, but you need to know. So, if I want the conditional statement to be true, and I already know that the consequent is going to have to be false because B is false. So, one of these two, right? One of these two has to be the case. This one or this one. The consequent is going to be false. So I can make E true. I have a true. No, that won't work. I did it wrong. Hold on. I'm going too fast. True antecedent, true consequent, true. False antecedent, true consequent. That's true. True antecedent, false consequent. That's false. So if I want my second premise to be true and the consequent is false, this has to be false. E has to be false. It cannot be true. Okay, so E is true. E is false. Okay, E is false, which means S has to be what? If I need to have a true disjunction and this is E is already false, S has to be what?
True.
Thank you. S has to be true, and that's okay, no problem there, right? I still have a true disjunction. So S is true, and if S is true and I negate it, it becomes false, right? So what is the value of U if this is false and I need to have a true disjunction? This has to be true so that at least one disjunct is true, which means U is false, right? So did we run into any problems or were we able to invalidate this argument? Is this argument valid or invalid?
Invalid.
This argument is invalid, and who can tell me why is this argument invalid? You can tell me the obvious, it's okay. I'll do it for you. You probably think that saying it sounds stupid because it's so obvious, right? We tried to invalidate it. We tried making the premises true and the conclusion false. And we were able to invalidate it. We ran into no problems. So what you could say is, under these value assignments, these truth value assignments, when you assign F to E, T to S, F to B, and false to U, this is the invalidating assignment that will give you all true premises and a false conclusion. And just for fun, so you can convince yourself, go ahead and draw it out. Do the long truth table, right? 2 times 2 times 2 times 2. You're going to be there for 16 rows. Do it, because you will find at least one row where you'll have these truth values and you'll have this altered premises and a false conclusion. Okay, so questions on this one? I want to do one more because and then this will be our last one, and then I'm going to move on to proofs. Okay. So this one, pay attention to this one. Okay, so the argument is not P or Q. Premise number 2, if R then Q, P and R. I hope you guys had a good weekend. I didn't get to say much hi. Okay, P, Q, R are letters, right? So again, we're going to try to invalidate this guy. I work so much in the legal system that I think it's like, we're going to make this argument. I feel like I'm old school in the medieval times when people would just accuse people of being guilty, Thankfully, things have changed. And now the burden of proof is on prosecution. People are innocent until proven guilty. Here, it's like we're going back in time. We are accusing this argument of being invalid. We're going to make the premises true and the conclusion false. And when you try to make it invalid, if you're able to invalidate it, obviously it's invalid. And if you cannot, then the argument is valid, right? Okay, so here's the tricky part about this. Whenever you have a conjunction as your conclusion, there's 3 ways in which conjunctions can be false. Remember? I don't like that. So the only time it's true is when both conjuncts are true, which means there's 3 different ways in which they can be false, right? So we want the conclusion to be false. So this is 1, 2, 3. And this is the only way to do this is to go by one. I'm going to start with number 1. Hopefully it will work. I'm going to make this conjunct false and this one true. We'll see what happens. So P, I'm going to make it false. If P is false and I negate it, it becomes true, which gives me a true disjunction. If R is true, that means that Q has to be true in order for me to have a true conditional, right? Can I make Q? Because if Q were to be false, then I would not be able to have a true conditional. So can Q be true? Let's see. True. And actually, it can. I'm going to go back and make sure that everything lines up. Sometimes you get lucky and the first one that you try works. Sometimes just because it doesn't work, it doesn't mean the argument is actually invalid. Right. So if I make P false and I make R true, I get a false conjunction, right? Because the only time that it's true is when both are true. Okay, so if P is false and I negate it, it gives me a true left disjunct. And that's P. Now we said that R was going to be true. Can R be true? Yeah, it can be true. No problem. There it is. Now I need to have a true conditional for my second premise. So it has to be the case if I need a true conditional, Q has to be true. It cannot be false because then I would have a false conditional, right? So Q has to be true. So I put it right there. And do you see how I don't run into any issues? There's no problems. And I'm just going to, for our reference, go back to this one. I try to make the premises true and the conclusion false. But then in my attempt at invalidating it, I cannot have two false disjuncts and have a true disjunction. That's impossible. I cannot. So so here I had no issues. So the argument is what? Valid or invalid?
Invalid.
Thank you. The argument is invalid. I got lucky and I picked number 1. And that's it. But let's try this one. Just imagine that I had decided, you know what, I'm going to try number 3 first. So number 3 is both are false, right? I'm going to try that one. So let's say that today I feel like I'm going to make both of them false. Okay, well, what would happen if I had started with that? And I'm doing this just to show you. If I had started with both false, then P would have to be false, which means the negation of that is true, and R would have to be false. Okay, so Q can either be, well, here, in order for this to be true, Q can be either true or false, right? Because disjunctions are true when at least one of them is true. In order for my conditional to be true, Q can also be true or false. So I'm going to make it false. And this is still true because at least I have one true disjunct. And if Q is false, this is still true. And so here's another instance where this is another invalidating assignment under which you can have all true premises and a false conclusion. You don't need more than one. All it takes is one row. And I'm going to do the last one, you guys, because I like to go one by one. I like to go one by one. And let's just say that today I randomly started and I decided I'm going to make P true and Q false. No, P true and R false. So if P is true and I negate it, this becomes false, right? And R, we said it was going to be false. So false, true, or false. Q can either be true or false. I'm going to make it true. And again, if Q is true, this checks, no problem, because at least I have one true disjunct. And so the whole thing is true. This is true, no problem. So under any one of these, this whole thing would have been invalid, which means that you would have different rows. If you did this in the long method, you would have different rows with at least 3 times when it would be invalid. So I ate up about 40 minutes over time just reviewing the short truth tables. What I'm going to ask you to do between now and Wednesday is for you to go over the assignments in the book and come up with a couple of 2 or 3 truth tables that you would like us to go over in class. Questions you may be having. What questions do you have? You don't ask me questions here, but because I'm going so fast, just remember you can text me and ask me. Okay. So now we begin proofs. Proofs are my favorite in logic. They're fun. They require memorization. Okay, so these are mini arguments, mini rules of deduction that will always be valid. And you need to learn these rules of deduction to solve proofs. Okay, so the ones we're going to be going over with this presentation are modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. And if I have time, I will also go over simplification, conjunction, addition, and constructed dilemma. So from here on out, we're in week 4. So for the next 4 weeks, we will be doing proofs. We will focus on systems of natural deduction in which one uses a set of inference rules to demonstrate step by step that the conclusion of an argument follows from the premises. A proof consists of a sequence of statements, the propositions, the premises, each of which is either a premise or is derived from a preceding statement by application of a rule of inference, and the last of which is the conclusion of the original argument. So this is a proof. Let's do proofs. Advantages to proofs is that they're not as cumbersome as truth tables. Also, proofs reflect more closely the way that we think. So the first one is called modus ponens. I remember monks did logic, so a lot of the terms come to us in Latin, if you speak Spanish. Modo means what? A way, the way, and poner means to put something, right? So the way in which something is put, long way of saying it. The way that this is a valid argument. If P then Q, is premise number one. P is the second premise, therefore Q. So no matter what you stick in this, it doesn't matter what you stick in it, this argument pattern will always be valid. The rule of deduction is called modus ponens. And so just for fun, right, I write, if Tom drinks a fifth of whiskey, let that stand for P, then Tom gets drunk. And then you find out that Tom drinks a fifth of whiskey, so therefore Tom gets drunk, right? And it goes for everything, right? If I drink a cup of coffee, I'm going to have to pee. I drink a cup of coffee, so I'm going to have to pee. What I need you to do is to use a flashcard. And one side of your flashcard, please write modus ponens. On the flip side of your flashcard, write if P then Q, P therefore Q. And also write that this is a two-line rule. You need two lines. You need two premises. Premise number one is if P then Q. Premise number two is P. So you need two premises in order to derive your conclusion. Let me demonstrate to you that this is a valid argument. Can you see what I'm sharing? I hope so. Were you able to see everything I just shared?
Yes.
Yes.
Thank you. Yeah, because sometimes I get going and then... Okay, let's go to the whiteboard again. Okay, so let's do a truth table for modus ponens. If P, then Q. P, so therefore Q. I will demonstrate to you that this is a valid argument. I'm going to use the short truth table method to make my premises true and the conclusion false. I'm going to try to invalidate it. I won't be able to because it's a valid inference. So if Q is false, right, you go here, and P is true. Is this possible right here, you guys? Can I have a true premise and a true antecedent and a false consequent and have a true conditional?
No.
No, it's impossible. I tried to invalidate it. This argument is. And so this is a rule of deduction, and that's our first one. Okay, now I want to go back and share my screen so we can continue. How do I go back and share my screen? Share. Okay, modus ponens. If P then Q, P therefore Q, two-line rule. The next one is called modus tollens, and it goes like this. If P then Q, not Q, so therefore not P. In English, you could say, if Tom drinks a fifth of whiskey, then Tom gets drunk. Premise number one, right? And then the negation of the consequent. Tom did not drink a fifth of whiskey. So therefore, Tom is not drunk. The negation of the consequent, right? So if P then Q, not Q, so therefore not P. If Tom drinks a fifth of whiskey, then he gets drunk. And then you see that Tom is not drunk. So you can safely infer that Tom did not drink a fifth of whiskey or of anything else because Tom is sober. Okay, so again, this one is the way in which something is taken away. And so this is how I'm going to ask you to please, actually, and for extra credit, I'm going to ask you to do flashcards for all of the rules of inference and show them to me so that I can give you extra credit for having your flashcards done. It's a two-line rule. You need two premises. You need the first premise, if P then Q. You need the second premise, not Q, to arrive at your conclusion. If P then Q, not Q, so therefore not P. Modus tollens. The next one, and if you want to run a truth table by that one, just so you can verify for yourself that this argument is valid, please do. A hypothetical syllogism. This one, if P then Q, premise number one, if Q then R, premise number two, you can safely conclude, infer that if P then R. It's a two-line rule, right? You need two premises. If I do my homework, then I will learn how to do proofs. And if I learn how to do proofs, then I will pass my logic class. So if I do my homework, I will pass my logic class in English. It's a two-line rule. In your flashcard, on one side of the flashcard, write hypothetical syllogism. On the other, the way that the rule of deduction looks like. Remember, it's a two-line rule. You need two rules to derive the conclusion. And when you are quizzing yourself with the flashcards, if you only look at the left-hand side, then on a blank sheet of paper, memorize it, right? Try to recall, how does the rule go? If P then Q and if Q then R, so therefore if P then R, right? And then jumble them all up and look only at the right-hand side. So then you recall what the name of the rule is. And if you do this for like 10 minutes each day, you will have memorized them. And you need to memorize them. Memorization is a step before you can start doing the proofs. The next one is called disjunctive syllogism. If P then Q. Okay, so the way that this goes is, I'm going to say it in English. I mean, all of it is in English, but I'm going to try to say it right. So just like regularly you would say, if P then Q, not P, therefore Q. If P then Q, not Q, therefore P. So I also like to say, given a disjunction together with the negation of one of its disjuncts, conclude the other disjunct. Given a disjunction together with the negation of one of its disjuncts, conclude the other disjunct. I will either drink a Pilsner or an ale. I won't drink a Pilsner, so I will drink an ale. Yeah, so this is a rule of deduction. We think like this, right? If you really like the shoes in brown and in black and you don't know, like, should I get them in black or should I get them in brown? And then you go look and then they don't have your size in black, you get them in brown. Okay. And again, this is how you do it. It's a two-line rule. You need the disjunction together with the negation of one of its disjuncts. So you need two lines in order for you to conclude the other disjunct. Okay. I wanted to tell you, it doesn't matter your discipline, right? This is human reasoning. And if you are going into mechanical engineering, right? Or if you are working in law enforcement and law or in medicine, you need to problem solve and work backwards, right? You have the sound that the machine is making, or you have the symptoms. Okay, well, what is the root of that, right? And so you have to go back and in order for you to trace the source of the problem, right? In order for you to find the culprit. So working backwards is one of the things. There's different ways to get from point A to point B when you type in GPS. I can, I work at Mission, but I live downtown, so there's different roads I can take. And this is where there's a level of creativity. Different people solve problems differently. But we need to follow the rules of deduction, right? You need to drive in the right-hand side and follow the speed limit, right? You can't just drive however you want. So there might be different roads to get to the same place, but you still need to follow the rules of traffic. So that's one thing. Think of the rules of deduction like tools. If you're trying to fry an egg, you're not going to use a ladle to fry an egg, right? You need a spatula. And if you're trying to pour soup into your bowl, the ladle is the appropriate tool. You don't use a spatula to pour soup into your bowl. Each tool has a different function. So each rule of deduction works in a precise way. If you try to use the Phillips with a flat head, it's just not going to work, right? So think of the rules of deductions like tools. That's a plate of risotto that looks really delicious. Tactics and strategy. If what you need to derive is a letter or expression that occurs as a consequent of a conditional, then one of the premises, try modus ponens. If what you need to derive contains a letter or expression that occurs as the antecedent of a conditional, you might try modus tollens. If what you need to derive is a conditional statement, then try to derive it by using a hypothetical syllogism, because you will get a conditional statement as your conclusion. If what you need to derive is one of the disjuncts in a compound statement, try using disjunctive syllogism. And so let's do some proofs. Let me see. Do we have any proofs in here? No, it's all blank screens. Okay, let's go into our. I want to show you. I want to do some proofs. Let's go to our ebook. Hopefully we can get in there. What chapter is it? I think it's chapter 8. Propositional logic. Can you all still see my screen?
Yes.
Chapter 8 is all truth tables, so it's not chapter 8, it's chapter 9. Okay, so this book calls it rules of inference. I call them implication rules. It's the same thing. Can I collapse that? Yes. Okay, so please read this. The way that modus ponens works. Well, all of them, right? Modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism, and the abbreviations. Okay, so let's do some proofs. And then it shows you how to do it. Okay, let's do. Let's do this one. This has 3 premises and 4 premises and 1 conclusion. Okay, let me take a little picture and then we're going to do it together in the whiteboard. Okay, whiteboard. And this is like, to me, you guys, I can do proofs all day. I have to tell you, once you memorize the rules of deduction, there's a level of frustration that one must overcome. But once it's like knitting, or playing an instrument, once you overcome that level of frustration, it's fun. Like when I learned how to swim as an adult. So once, you swallow some water and you get over, your frustration and fear, it's just fun. Okay, so premise number one, let's just say you have this argument, right? If P then T, if T then S, either M or not S, and my fourth premise, not M, so therefore not P. P then T, if T then S, either M or not S, not M, so therefore not P. Okay, so my premise number one, this is how you set it up. You can do a parentheses or just a dot. Premise number one is if P then T. That's my assumption. I've worked with different systems of deduction, so sometimes it's like an ampersand or an arrow may show up in there, I hope I'm not throwing you guys off, but I mean well. M or not S, premise number 4, not M, and then you separate them and you say your conclusion, you write it in there, right? So the first 4 premises is the material that I am given, the cues I'm given to solve for not P. This is my final destination. Okay, so premise number 5. Okay, I take a look at my proof, right? I take a look at my cues like Sherlock Holmes, right? Like, okay, I need a not P. Do I have a P in my premises? Yes, I do. It's the antecedent of premise number 1. So if I could get a not T, I would get a not P, right? By modus tollens, because that's the way that modus tollens works. So I already have this one. How can I get my not T? Well, I have a T in line 2. And line 2 happens to be a conditional statement. And if I had a not S, I could get my not T by modus tollens, right? So I need a not S. You see how I'm working backwards? I have a not S in line 3. What rule can I use to get my not S isolated? You tell me the name of the rule. Given a disjunction together with the negation of one of its disjuncts, I can conclude the other disjunct. And that I use lines 3 and lines 4. And the name of the rule is called disjunctive syllogism. So on the left-hand side of the proof, you write your premises and line by line the next rule of deduction. And on the left-hand side, on the right-hand side, this is called the justification. This is how I show anyone who's reading my proof how I got to line 5, because line 5 was not given to me. But I'm telling you, on line 5, I can write that not S, because if I have line 3 and line 4 and I apply disjunctive syllogism to lines 3 and line 4, I can get my not S in there. So, okay, I have my not S. And the reason I wanted my not S was so that on line 6, I could write not T. And the lines of deduction that I use were lines 2 and lines 5. And what rule of deduction did I use? What goes in there? If T, then S, and then I have not S, I can conclude that not T. Do you guys remember the name of the rule? It's called modus tollens. Okay, and the reason I wanted my not T, there was a reason for it, right? Because now, look, line 1 together with line 6, by applying modus tollens to those two lines, I can conclude that not P. And so there, I have given these 4 premises, I have proved that from these 4 premises, I can derive that not P follows. So I have proved not P. And when you're done, you write, which in Latin means it has been demonstrated. So that's one proof that we did. We're going to do more, but just giving you a sense of how these things work. And the way to do it is just to do a ton of them. Questions on this one? You can go back and review this once I post the link to the video of the lecture, but let me go back to the book. And I have 10 minutes, not quite 10 minutes. I still would like to do simplification, conjunction, addition, and conditional and constructed dilemma. I think I'm going to do another proof. You know what? I'm going to give you more slides, more this was the implication rules, right? Modus ponens and everybody. Okay. So then we're going to do this one. Come on. Okay, sentential. Implication rules 1, implications rule 2. Okay, so this is going to be simplification, conjunction, addition, and constructed dilemma. And I'm going to go through them really fast, and hopefully we can do a couple of proofs. So simplification, it's a one-line rule. You only need one line. And so the way it goes is, given a conjunction, you can conclude either conjunct. Because if you remember for the true tables, when you have a true, the only way to have a conjunction is if both conjuncts are true. So since both of them are true, you can derive either conjunct, right? If I say I went to the store and I brought bread and milk, you know that I brought bread as well as you know that I brought milk. So for your flashcard, please on one side write simplification, and on the other, both of the ways in which simplification can work. If P, well, given P and Q, you can conclude P. Given P and Q, you can conclude Q. And then test yourself, right? On one side, cover one side, or on one side of your card, when you have simplification, go to a scratch sheet of paper and then just write, how does this rule of simplification work? And then you You write it, and so you can test yourself. Conjunction goes the other way. This is a two-line rule. You need two things to put together. If in premise number 1 says this class is boring, and premise number 2 says I'm falling asleep, you can infer this class is boring and I'm falling asleep. It's a two-line rule. You need two premises to put them together, to conjoin them. Addition. This is one of my favorite rules. I call it the magic rule because you can make stuff appear. If you remember, in order for a disjunction to be true, all you need is one disjunct to be true. It doesn't matter what the other disjunct says. So as long as one of the disjuncts is true, you can add whatever you want to the other disjunct. So I could say, if I know that my name is Kim is true, I can say either my name is Kim or Elvis has left the building. Because it doesn't matter what the value of the other disjunct is. That's still true. Either my name is Kim, which is true, or Elvis has left the building. That's a true statement because at least one is true. EPCC Tejanos are smart. We know that is true. So either EPCC Tejanos are smart or Pluto is a planet. Okay. And so again, I'm sharing it with you, right? But the best way, this is like a hands-on thing, right? I'm sharing with you, this is how it's supposed to, this is how it works, but we need to do proofs in order for us to like learn how to apply it. It's a one-line rule. All you need is that one premise that is true, and then you can add whatever you want to it. It's a one-line rule. Constructed dilemma there, I think the book shows it to you. In the left-hand side, it gives you the conjunction of two conditionals. What that means is that I give it to you on the right-hand side to explain it. Notice that it's the same information on the left and on the right. It's just written differently. So the first premise on the left, I give it to you as the second and third premises on the right. And the second premise on the left is the first premise on the right. So let's look at the information on the right, because to me it's more intuitive. Let P stands for I will practice doing proofs. And R stand for I will take a nap. So premise number 1 says, I will either practice my proofs or I will take a nap. If I practice my proofs, then I will do well in my class. And if I nap, I will be well rested. So consequently, my conclusion is I will either do well in my test, in my class, or I will be well rested. Do you see? P or Q, if P then Q, and if R then S, so then either Q or S. And that information is the same as on the right, on the left. But the way that the book shows it to you is as a conjunction of the two conditionals. But notice that the second premise is a disjunction that contains the antecedent of both conditional statements. And so when you have that combination, you can conclude the consequent of both conditional statements. That is called constructive dilemma. And so it's a two-line rule. You need the conjunction of both conditionals together with a disjunction made up of the antecedent of both conditional statements. And then you can derive the consequent of both conditionals. Okay, and then I give you a bunch of tips. Please go over them. You can find these in the notes that I provide to you. Implication rules must be applied to entire lines in a proof, not just to parts of lines. We construct proofs by means of one application of one rule of inference per line. Indicate the annotation or justification on the right. Okay. I have 5 minutes. Maybe I can do 1 or 2 more proofs. Let me just make sure who's here. It says here that I have 6 people. I got Arlene, Juan, Lisbeth, Rosa, and Skylar. Great. While I set this up, do you all have questions? I don't know why the book is being funny like that. It's like blocking me. Okay, let's do that one. Let's do this one. Let me see if I can do like an easy one. And then do a more complicated one. Okay, so come here and go back to okay, let's go to this one. This one, I don't know what page it came from. But it's problem number 5. Premise number 1. Premise number 1, okay, premise number 1 says either J or K. Premise number 2 says it is not the case at J. Premise number 3, if K, then L, so therefore L. Okay, so L is my final destination, which I already have. I'm working backwards. I already have in premise number 3. If I had a K, I could use modus ponens, remember? If K, then L, K, so L, by modus ponens. So if I had the K isolated somehow, which I don't have right now, in 1, 2, and 3, but if I could get K in a line of proof by itself, I could apply modus ponens. I do have a K in line 1. So look at line 1. Remember? You're fine. No, you're good. Look at line 1. Line 1 says either J or K, not J. So therefore, given a disjunction together with the negation of one of the disjuncts, conclude the other disjunct, right? Remember? So why should I write right here on line 4? Given a disjunction together with the negation of one of the disjuncts, conclude the other disjunct. And the lines that I used were lines 1 and lines 2. And the rule of deduction is called disjunctive syllogism. I wanted that K so that I could do this. Look, lines 3 and lines 4, given a conditional, together with the antecedent, conclude the consequent. And the rule of deduction is called modus ponens. And there it is. I have proved that from these three premises, I can derive that L is the case. And it's 220. So I will see you guys Wednesday. I'm happy to stay here a few more minutes if anybody has any questions, but I don't want to keep you. So please practice, memorize your rules. Thank you. Let me know if you have questions. So Lisbeth or Skylar, do you all have questions? What questions do you have?
Not at this moment, no.
Okay. And Lisbeth?
Yes, I have a question for the second problem. How do you get like for number 4? How do
Okay.
you get the key for itself?
All right, let's go in there. Can you see my whiteboard?
Yes.
This one right here, right?
Yes.
Okay. Let's do it together again. Okay, so in the book, gives us these. Oh, I don't know why it does that. Okay, the book gives us line 1 says either J or K. Line 2 says it is not the case that J. And then line 3, premise number 3 says if K, then L. And then our conclusion says prove that L. Prove that L follows from those 3 premises. So I've been doing this for a while, right? And it's like when you're learning how to cook and somebody who has been cooking for a long time, like they just don't even have to look at the recipe. Like they already know. And so they just do it. But so I've been doing this for a while, so that's why it looks easy. And I'm trying to break it down so that you can see what I'm doing. What I'm trying to do is think about it like this. This is my location. This is point A, and this is my destination. So how do I get from here to there, right? So what I need to do is prove that L is my final destination. Okay, I do have an L in line 3. And I know the way that modus ponens works, is like this. It's like if you have a Phillips, if you have the little screwdriver that has the little cross on top, you automatically know to reach for a Phillips, right?
Yes.
Or if you're gonna ladle soup into a bowl, you reach for that the ladle, that tool. You don't reach for a spatula. You know you're gonna need like a ladle, right, for the soup. So you automatically know. And so I ask you guys to memorize the rules of deduction, to put them in the flashcards, because that's how you know what rule goes where. Okay, so modus ponens works like this. Given a conditional statement together with the antecedent, you can conclude the consequent. That's called modus ponens. And so that looks like this. That's line 3. And if I had a K, I can conclude it. I could conclude that L. So now what I need to do is find a K. And if I look at line 1 and line 2, given a disjunction together with the negation of one of its disjuncts, I can conclude the other disjunct. This is called disjunctive syllogism. And that has the same pattern as line 1 and 2. Given a disjunction together with the negation of one of its disjuncts, I can conclude the other disjunct, which is the guy I want right there, right?
Right.
So at line 4, I can write, given a disjunction together with the negation of one of its disjuncts, I can conclude the other disjunct. So that came from, it's a 2-line rule, 2 lines. So I use lines 1 and 2, and I use disjunctive syllogism. And the reason I want it, so I can write K right there, but I have to justify it. So this is my justification here.
Oh, okay.
Yeah, and then let me go ahead and finish. So then I'm not done because I still have not solved for L. But look at lines 3 and 4. 3 and 4 have the pattern of modus ponens, right? Given line 3 is right here, given a conditional statement together with the antecedent, I can conclude the consequent. So right there. And now I'm done at line 5, right? But I still need to justify it. Where did that come from, right? So it came from line 3 and line 4. And I used the rule of modus ponens. And now I'm done.
Okay.
It makes sense, right? Because it's logic.
Yes.
But how did I know to use disjunctive syllogism? How did I know to use modus ponens? It's like you develop the intuition to know what you see patterns. So how do you know to use a spatula when you're trying to make an omelet, right? And turn the omelet around? How do you know to use a spatula and not to use a ladle? How do you know to use a screwdriver and not pliers? You need to know which rules to apply when.
Okay. Yeah, I just got lost on the part where you got the K. But yeah, I get it now.
Okay, you work backwards. It takes a lot of practice. Step 1 is to memorize the rules. Do the flashcards.
Okay.
Okay, if you have any questions between now and Wednesday, please let me know.
Okay. Thank you.
Thank
Have a
you.
nice day.
You too. Bye-bye.